All right, your teacher here, Mr. Sharasinski, working on some Algebra 2 midterm review. First, we got the non-calculator section. What would a value of x make, or what value of x would make this a relation? Well, remember, if it's a relation of function, if it's a function, x values cannot repeat. So whatever value you choose cannot be 7, 8, -2, or 4. So 8, 4, but 12 is okay, because 12 is not any of those x values. What is the vertex of the following? In vertex form, the vertex is h and k, and remember, h is always the opposite. So it's -3, -1. So the answer is C. All right, 3 is the following function even or odd? Odd. All right, so based on what I have researched just now, all cubic functions are odd. Absolute value functions are even. Hold on, I'm going to tell you a few more. Where is it? Okay. So yeah, absolute values are even. I'm thinking if absolute values are even, then quadratics are even because they're symmetrical. So if they're not symmetrical, they're odd. Okay. And that is not the formal definition. All right, number 4, select the graph of the following equation. Well, let's look for the vertex, right? The vertex should be at 6, 0, since there's no k. And it looks like the only, let's see, we got A has got a 6, 0, B does not, C does not, or D does not, and C does not, so it has to be A. Number 5, select the equation of the following graph. All right, so we got a vertex at -2, so this should be, definitely the absolute value of x minus 2. All right. Now, it's shaded below, and it's a dotted line. So I know if it's a dotted line that it's got to be greater than or less than, and since it's shaded below, it is less than. D. Okay. Next. All right, number 6. True or false is the following relation a function? Well, do any of the x's repeat? So we got 1, 3, 5, and 6. They're all different. So yes, that is a function. Is the following function even, odd, or neither? Well, let's see. It has a degree of 5. And if it has a degree of, oh wait, hold on. So we're gonna, so it'll be x times x cubed plus 8. All right, I am not sure about the quintic function. When I did Google it, it said has an odd degree and it's similar to a cubic function, and since it was similar to cubic, I said it was also odd, but I am not sure. But I'm like maybe 75% on that one. All right, number 8. If you're graphing linear inequalities, you need to know 2 rules. Greater than or less than, you got a dotted line. Greater than or equal to, less than or equal to is a solid line. And then greater than or equal to, you shade above. Less than or equal to, you shade below. All right, so we've got a coordinate plane. I know it starts at -6, so I'm going to make 6 tick marks and put a dot there. Doesn't have to be perfect. The slope is up to right 1. Let's make those a little closer together. There we go. So up to right 1, up to right 1. Hold on. I don't love where that dot dot is. All right, so up to right 1, up to right 1, up to right 1. And since this is less than, it's a dotted line. And we shade, since it's less than, below. So the solutions are on this side. All right, number 9. 3x squared plus 16x minus 12, factor it. AC method, 3 times 12 is 36. So we need factors of 36 that add to equal 16. See, 36, 18, and 2. There it is. Positive 18 minus 2. So 3x squared plus 18x minus 2x minus 12. And then we're going to group. So this is the AC method. GCF of 3, and you're left with x squared plus 6. And our signs are different, so I know I need to take a negative out. Take out a negative 2, and I get x plus 6. Oh, this should have been 3x. Sorry about that. All right, so now my GCFs come together, 3x minus 2, and my binomials come together, x plus 6. All right, number 10, solve the given equation. All right, 3x squared plus 8x equals 12. 3x squared plus 8x equals 12. We got to get everything on one side, so subtract 12 from both sides. And then we can set it equal to 0 and solve. Now we are doing, let's see, AC method again. 3 times negative 12, negative 36. We need factors of negative 36 that add to equal 8. How about, let's see, 36 and 1, 18 and 2, 12 and 3, 9 and 4, 6 and 6. None of those will give me 8, which means that I cannot use the AC method. I think I need to use the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4 times a times c, negative 12, all over 2 times a. All right, so I always do the part inside the radical first. All right, so that's going to be 64 minus, or no, negative 4 times 3 is negative 12. Negative 12 times negative 12 is positive 144. And so I get 210, I think. 208. 208. Okay, so I have negative 8 plus or minus the square root of 208 divided by 6. And the square root of 208, let's see, let me see if that will simplify. All right, number 19, sketch a possible graph of the following polynomial. So we got, x plus 4 squared. So that's going to be, this one I'm not sure about. X cubed, all right, with the maximum number of complex roots. Again, these two I need you to do some work on. Write the expression that is equivalent, okay? So we need to try to factor this. So maybe we can eliminate one of the factors in the numerator. So 4x cubed plus 12x squared, I'm going to group those two together, minus x minus 3. So in the first grouping, it looks like I can take out a 4 and an x squared. And if I do that, I'm left with x plus 3. And the signs do not match, so I know I need to take out a negative, but everything else matches. So I'm just going to take out a negative 1. So I get 4x squared minus 1 times x plus 3. Now, 4x squared minus 1 is a difference of squares. So that's 2x minus 1, 2x plus 1, x plus 3. And since we're dividing by 2x plus 1, those cancel out, and I'm left with 2x minus 1 times x plus 3. And if they want you to simplify it more, you would just FOIL it out. You would get 2x squared, 6x minus x, that'd be plus 5x minus 3. Okay, 22, write an expression that is equivalent. Well, x cubed minus x can be factored, and you can take out an x, and you're left with x squared minus 1. And x squared minus 1 is a difference of squares. So then you're left with, and I'm going to run out of room here, x times x minus 1 times x plus 1. And since we're dividing by x minus 1, we're left with x times x plus 1. And that could be enough. But if it's not, you can always multiply and get x squared plus x. Okay. Number 23, given the function y equals negative 4 divided by x plus 2 plus 3, state the transformations and asymptotes. Now, this is in standard form. You need to find the standard form equation and then compare them. But since x is having something added, I'm going to say it's going to go left 2 and up 3. I think a is negative, so that's going to be a reflection over the a, or over the x. Okay. And I think a is 4, so that's probably a stretch, but I'm not sure. Okay. Next page. Given the function y equals 2x to state the wholes, you're going to have to look at the rules. I don't remember those on this one, but I do know that that denominator is going to factor, and that'll may or may not help you find the wholes. So 2x plus 3, and then 4x squared minus 9 is 2x plus 3, 2x minus 3. Okay. 25, simplify. Remember, when you divide, it's like multiplying by the reciprocal. So that would simplify to 5 parentheses x plus 1 over 10 parentheses x minus 1. 3x squared minus 3, you can factor out 3, and you get x squared minus 1. So x minus 1, x plus 1. And then this will be x plus 3, x plus 3. All right, so now what can we multiply or cancel out? Well, x minus 1s will cancel out. All right, so then we're left with 5 x plus 1 squared over x plus 3 squared. Oh, wait, over 10 x plus 3 squared, which simplifies to 1/2 plus 1 squared. X plus 3 squared. There we go. 26, you have to have common denominators. So we got x minus 3, x plus 3, and x plus 3, x plus 2. So this one needs an x plus 2, and this one needs an x minus 3. So we've got 5x times x plus 2, and we've got 4x times x minus 3. Okay, that's 5x squared plus 10x minus 4x squared plus 12x. So that's x squared plus 22x over x minus 3, x plus 3, x plus 2. And the only thing I can do with the x squared and 22x is take out an x. And I do not think anything else is going to simplify. Okay. All right. That gets you to the calculator stuff. And I hope that with that, you are able to work through the rest of this with some confidence. Sorry I didn't finish the whole thing, but I got you most of the way. I am your tutor. This is the way.